All right, page 4, radicals, number 10a. So remember again, first thing we want to do is break down that number by factoring it out with the birthday cake method. Or you guys can remember you can do the tree, that's fine too if you want to divide 2. Either way works. I prefer this way. So again, to divide by the smallest prime number you can think of that will divide into there, and that's 2. Divide that by 2, that's going to be 54. I can divide by 2 again. That's going to be 20, what is that, 27? Okay. And then I can't divide 2 anymore, so now I divide 3. That gives me 9. Divide 3 again, that gives me 3. And I can divide 3 by 3. And I don't get 1, I get a birthday cake candle. Okay, so now, again, remember the index is 2. And pretty much all these problems, the index is 2. Okay, so we're going to circle groups of 2. So I get a group of 2 there, a group of 2 there, and I still have 1, 3 left. And one number from each of these will go outside. So then I'll have 2 times 3, and then 3 on the inside, and then multiply that together, and I get 6 rad 3. Okay, so now here, again, don't let it freak you out. It's very simple. Okay, just split it up. Okay, if I have a fraction, all I do is square root the top, then square root the bottom. So square root of square root of 49 is 7. Square root of 144 is 12. And then just multiply the fraction and the negative 10. Negative 10 times 7 is negative 70 over 12. And then try to simplify it as much as possible. I think I could divide, let's see, we'll try 2 first. So that would be 35 over 6. And that's it. And don't forget the minus or negative there. Okay. This one, again, birthday cake, same thing. Okay, so 90, divide by 2 is 45, then divide by 3 is 15, divide by 3 again is 5, and then I have to divide the 5 there. If you notice, I only have 2 3s, a group of 2 3s, so that's what's coming outside. So now, again, if I already have a number out there, don't forget about it. So now I multiply it times 3, and on the inside I still have this 5 and the 2, so that becomes 10. And then multiply 6 times 3 is 18. 18 rad 10. Okay? Okay, now again, if I have 2 radicals, in order to add or subtract them, they have to have the same radicand, or the number inside. So this, I can't factor that out anymore, but I can do the 27. So I divide by 3 is 9, divide by 3 is 3, divide by 3 is birthday cake candle. So now I could take a group of 2 there. So rewrite this one. So now this becomes 3 rad, and then don't forget that 3. And so now you treat this one like it's a minus 1. And again, this is like minus 1x minus 3x, which is just minus 4x. It's the same thing. Minus 1 and minus 3 is minus 4, and then the radicand doesn't change. So negative 4 rad 3. Okay, same thing here. Except I have 3 different radicals I got to do it with. Okay, so first we do 500, divide by 2, it's 250, divide by 2, I'm making it really small because these are big numbers, that gives me 125. Let's see, can I divide 3? No, I can't. So one trick, if you don't already know this, if you add up each digit, okay, 1 plus 2 is 3, plus 5 is 8. If that number, if you can divide it by 3, then that means I can divide it by 3. But I can't, so I know that 5 works. Okay, so it's a 2, 2, 5. Okay, so then 25, and then 5 again. Gives me 5, and then 5 again. So now I have a group of 2 2s there, 2 5s there. So then that means 2 times 5 is 10, and then the inside I just have the 5. Okay, so now I'm going to do that with 125 over here. And I kind of already did part of that here, but I'll just repeat it. So you could just jump ahead and say, oh, well, I just did 125 there. It's 3 5s. Okay? But I'm just going to show it. Okay? So I got 3 5s, so that means 2 5s there. And remember, it's 2, because there's already a 2, times 1, the 5 that you brought out. And then I still have a 5 on the inside. Okay, then here, for 45, okay, divide by 5, it's 9, divide by 3, it's 3, divide by 3. Okay, so that means that I take out a 3, and leave the 5, and boom, I've got 5 all the way across. First, I'm going to multiply that, the 2 and the 5 there. And again, just add up the numbers outside. So now 10 plus 10 is 20. Okay, then subtract 3. Oops, I wrote a 3 there. Okay, so 20 minus 3 is 17. 17 rad 5. Okay? Now radicals in the denominator. We don't like that. So in order to get rid of that, if I multiply it times itself, times rad 2, that just becomes 2. But then if I do that to the bottom, or the denominator, I have to do it to the top, the numerator. Okay, so now this is 8 over rad 2, or 8 times rad 2. But then remember here, okay, that's 8 over 2. I can simplify that. That cancels out to 4. So then this is 4 rad 2. Okay, now this, okay, remember with this, I can't just multiply rad 6 here. Okay, but what I can do is I can multiply the conjugate. So remember the conjugate is minus the square. Okay, so I'll do the same thing on the top. So first let's distribute that. 2 there, 2 there. So 2 times 1 is 2. Then 2 times rad 6 is just 2 rad 6. Okay, and remember what I told you is that the first number is squared, so 1 times 1. And then the last number minus the last number squared. Well, the last number squared, basically the square of the square root of 6, all that does is cancel out the radical. So now it's just 1 minus 6. So now I have 2 minus 2, and then 1 minus 6 is minus 5. And I'd be okay with you guys leaving it like that. But what you could do is bring the negative outside, because it just looks cleaner. Now, again, this is extra. You don't have to do this. Bring the negative outside, then that's a clean positive 5, and then what I'll do is redistribute that negative to the top. So I'll distribute the negative there, and now this becomes negative 2 plus 2 rad 6 over 5. And again, either is fine. Okay, but typically what you want to do with math and these types of problems is get this number to be as simple as possible, and that's why I got rid of the negative on the bottom and transferred it to the top. But again, that's extra. You don't need to do that. Okay, now here, again, this is similar to F, so all I got to do is multiply the bottom times rad 11, top times rad 11. Okay, those cancel out to become 11, but then I still have 5 down there. Okay, then here what I have to do is multiply the inside of the radicals because they're not the same, so they don't cancel out. So now this becomes square root of 55. Okay. Now if you notice, I have 11 on the bottom, 11 on the top. Those would cancel, but don't forget the negative. So that'd be minus square root of 55 over 5. Again, if you missed that because I saw it wasn't on the video, I canceled the 11s because I have 11 on top, 11 on the bottom. Okay, now the complex numbers. Okay, so remember, these have 2 parts. We have a real part and then the imaginary part. Okay, so first let's add up the, well first actually if you notice there's a negative here, so what I've got to do is distribute that negative. And I can take away the other parentheses once I do that. This becomes plus I now. And that's just plus, so I can take away those parentheses. Now combine all the, you could say like terms. So first we'll start with the real terms. Negative 13, negative 17 is minus 30. And then we add the other negative 11, so minus 41. Okay, then the i's, or imaginary numbers, 5i and I, 6i, plus 18i, 14i. And there's your complex number. Okay, so remember you have a real part and you have to have the imaginary part. Keep them separate and always put the real part first. Okay, so now we're going to distribute. Okay, so 6 times 9 is 45i. 6 times 7, or 6 times negative 7 is negative 42. But now we have I times I, so I squared. Remember, I squared is equal to negative 1. Sorry. So this just becomes negative 42 times negative 1, which becomes positive 42. And again, if you can see the steps ahead of time, you don't have to write as many steps as I do. You could just jump to your solution there. So 42 plus 45i, because you want to put the imaginary part second. Like in this video, Ayub likes to come up to me and correct my mistakes. So all you guys are like, "Hey, Mr. Osborne, you're wrong." Yes, yes, yes. I know it's 54. Okay. So now 45. So this is 54. I'll just change that. And I didn't use pencil. This is why I always tell you guys. Everybody tells you use pencil, so you have to scratch it out. So 42 plus 54. Thank you, Ayub. A+ on the test. Just kidding. As long as you study. All right. So now I to the 30. Okay, so remember we want to cancel out every four i's. Okay, because every 4 i's is equal to 1. All right, so what I'm simply going to do is just see how many times 4 goes into 30. So all I'm going to do is just do 30 divided by 4. Okay, I'm going to do this old school. You guys did in elementary school like this one. Okay, well 4 goes into 37 times with a remainder of 2. So I don't care about that. I care about the remainder because that's all that's left. Okay, because this is basically I to the 4th times I to the 4th times I to the 4th and so on. Okay, and each of those I to the 4s is equal to 1. So those basically cancel each other out. But now I have a remainder of 2, so that means I have I squared. And again, I squared is minus 1. And that's it. Okay, so we didn't get a chance to go over this one. Okay, but this is not as hard as you think. Basically, if I get a negative on the inside of a radical, what I'm going to do is take that negative or separate it. Okay, so negative 1 times 196. Okay, let's separate it again. Negative 1 square root of negative 1 times 196. Now, if you remember, square root of negative 1 is equal to I. So then that takes out the negative, and now all I have to do is do the birthday cake with 196 and simplify. So now 196 divided by 2. Okay, that's going to be 50 plus 48, so that'd be 98. Let me just double check that. Is that right, guys? Yes. Okay, I'll just ask the guys sitting in here. All right, so then divided by 98 divided by 2, 49. Okay, and then I know the only number that goes into 49 would be 7. So then there's my group of 2. That 2 comes outside. And then what I'm left with is 7 on the inside. And just do multiply 2 times 4 is 8i times rad 7. It's like I need more coffee. So divide by 7. Lava corrected me this time. Okay, is 7. Then divide 7. Okay, so that means I also have another group of 7s. Okay, so let's go back a couple steps here. All right, so that means that a 2 and a 7 come out. Okay, and if I have nothing left, that means the radical is gone. Yay, happy day. So then 4 times 2 is 8, times 7 is 56i. That looks beautiful. Okay, last one. Again, here you can use 2 methods. You can FOIL. Okay, first, outside, inside, last, or do the box like I like to do. Okay, so I'm going to put negative 1 here, 7i here, 3 here, minus 8i here. So the negative 1 times 3 is minus 3. 3 times 3, or 7 times 3 is 21i. And then negative 1 times negative 8 is positive 8i. Okay, then 7 times negative 8 is minus 56, but then I times I is I squared. Zoom in a little bit, because it's getting kind of tiny, like Vivian's handwriting. Okay, now I squared is negative 1, so then this cancels out to be 56. So again, I'm going to combine negative 3 and positive 56, that's 53. and then 21i and 8i is 29i. Alright, that is it. Enjoy.